So very good afternoon, students. Good afternoon to all of you. So happy to see you all, and good afternoon, Sri Lakshmi. Good afternoon. So just let me know if I'm visible and audible to all of you or not. So I have launched a poll. You can give your answers over there. Just tell me if I am visible and audible. Okay. Am I not audible? So I'm visible and audible to all of you, right? Yeah, okay. Fine. Great. So now let's go ahead with the periodic table lesson. Okay, so yesterday we have started this, and I have discussed about the modern periodic table and some informations related to periods and groups, etc. Right? So now let me give you a recall test, okay, which will be helpful to recall the yesterday's session. So I have got two questions for you, and you are going to answer for those two questions. The first question is, what is the other name for group 1 elements? Can you give your answer in the chat box? What is the other name for group 1 elements? What is the other name for group 1 elements? Very good. So the answer is alkali metals. Alkali metals is the correct answer. Very good, students. So I wish all of you could give me the answer in the chat box, not only very few. Okay. So only Jain B. Shimoga, Shivanand, and Sri Lakshmi has given me the answer. So I want all of you to answer the questions. Got it? So the second question is, how many elements are there in fourth period? How many elements are there in fourth period? How many elements are there in fourth period? Very good. Yes. Yes. Very good, students. So the correct answer is 18. So 2, 8, 8, 18, 18, and 32. Right? So the fourth period contains 18 elements. So this is all about the recall test. Now, let me continue with the topic which I have discussed at the last yesterday's session. So it was the blocks in the modern periodic table. So totally how many blocks are there in the modern periodic table? 4, right? S, P, D, and F. Very good. So S, P, D, and F. So yesterday we have discussed about the S block elements. So there were two groups and etc. etc. Informations related to that we have studied yesterday. So today we are going to move into the P block elements. Okay. So the P block elements consist of, yeah, the P block elements consist of 6 groups from group 13 till group 18. Okay. So the outermost electronic configuration for P block elements is NS2 NP126. NS2 NP126. So if I go for the boron group, which is the 13th group, the configuration will be, the outer electronic configuration will be NS2 NP1. And for 14th group, it is NS2NP2. And for 15th group, it is NS2NP3. Okay. So for 16th group, it is NS2NP4. For 17th group, it is NS2NP5. And for 18th group, it is NS2NP6. So the entire outer electronic configuration for the entire p block element is ranging from NS2 and NP1 to 6. Okay. And S block elements and P block elements together are called as main group elements. The other name for S and P block together is called as main group elements. And the 16th group specifically has some name. The name of the 16th group elements are called as chalcogens. The other name for 16th group is chalcogens. Okay, so 16th group means oxygen family. Oxygen, sulfur, selenium, tellurium, polonium, and livermorium. So all these elements are called as chalcogens. And 17th group elements also has one special name, okay, which are called as, very good Sanket, it is called as halogens. 17th group elements are called as halogens, and the 18th group is also having one name. The name is noble gases. The name for 18th group element is noble gases, and the outer electronic configuration for noble gases is NS2NP6, right? So the p orbital is fully filled. So p orbital can take only 6 electrons, and all the 6 electrons are there, okay, which is fully filled. So the 18th group elements, it is very difficult to lose the electron or gain the electron. So what they will do, they will not react with anyone because they are not in the capacity to gain or lose the electron, right? So only if an atom gains or loses some electron, we can say that the particular element is more reactive. Okay, it is reactive towards this, that, etc. But if it could not give or gain electron, then we will say that the element is having the low reactivity thing. Okay, so it is very difficult to lose or gain electrons. So the reactivity of noble gases is very, very less. Okay, clear up to this for all of you? So the first thing is electronic configuration. Second point is the other name for S and P block. And the third thing is about the other names for group 16, 17, 18. Clear to all of you? Shall I go for the next slide? In the next slide, we'll try to discuss some more information about the P block. Shall I go ahead? Any doubt from this for anyone? Any doubt? No, no doubt. Very good. So now we will go ahead, okay? Yeah. So here for P block elements, on moving down the group, the metallic character increases. Okay, so like S block elements, yesterday we have discussed, no? On moving down the group, the metallic character increases. So if I take this 13th group, which is a boron group, so it starts from boron, aluminium, gallium, indium, thallium. Okay, so thallium and indium, if you see, they are more metallic in nature, but boron is not. It is not a metal. It is a non-metal. Okay, boron is a non-metal. Okay, so like this, the metallic character increases on moving down the group. Next, coming to the non-metallic character, it increases across the period. Okay, so if I take boron, carbon, nitrogen, oxygen, fluorine, and neon, neon is having the more non-metallic character. Okay, so actually they are gases. Got it. Now, if I compare group 16 and 17, fluorine will be more non-metallic in nature compared to oxygen. Okay, so especially group 16 and 17 can easily gain the electron. The elements which are present in group 16 and 17 can easily gain the electron from the other species. So that's why in most of the cases, if you see oxygen, Oxygen can gain 2 electron and it can exist in O2 minus. And in some cases, if you see for fluorine, fluorine will gain 1 electron and it will exist in F minus form. Okay, so like this, if an atom gains an electron, it will take the negative charge over it, and this is more feasible for group 16 and 17 elements, which they can easily keep. Got it? So this is all about the P block. Next, coming to D block elements. So the D block elements has the transition of properties taking place from S to P. That's why D block elements are also called as transition elements. Okay. So in the periodic table, we have the D block elements in the center, right? Left side we have S block and right side we have P block. So the some of the properties for D block are similar to S block and some will be similar to P block. So it is transition. This D block has both the properties. That's why it is placed at the center of the periodic table, and it is also called as transition elements. It's also called as transition elements. Okay. So these are the four D series, which is there in the periodic table. 3D, 4D, 5D, and 6D. So there are four D series we have in our periodic table, and the D block occupies from group 3 till group 12. Okay, so this is the information regarding the D block. And if you want to know the outer electronic configuration for D block, it is n minus 1, D1 to 10, and n is 0 to 2. N minus 1, D1 to 10, n is 0 to 2. So this electronic configuration is very important. Okay, it is very, very important. And if you go for the last group, which is the zinc group, the zinc, cadmium and mercury. So these three elements does not show most of the properties of this D block. You know why? Because of its electronic configuration. So it has n minus 1d 10 ns2. So you see here the d electron has 10 electrons. The d orbital has 10 electrons, which is actually the fully filled configuration for d orbital. Okay, so again the giving and taking thing will be very less. The donation of electron and the gain of electron thing will be very less. It will not react mostly with the like other D block elements. Okay. Other D block elements are all are metals actually, and mostly they form colored ions. They exhibit variable valency. They have paramagnetic character, and they are used as a catalyst. So all these are the properties of D block, which we will be discussing in class 12. Okay, we have a separate lesson called D and F block elements. So in that lesson, we will discuss each and every property of this D block element in detail. Okay, now let me jump to F block element. So regarding this D block, the electronic configuration is very important. Okay, and you should memorize at least the first 30 elements given in the periodic table. Okay, which will include this 3D series also. So you will have from scandium till zinc. So you need to memorize at least the first row of this D block. Okay. Next, coming to F block. So in F block, all are metals. All of them are metals again in F block elements. And the outer electronic configuration for F block is N minus 2, F1 to 14, N minus 1, D0 to 1, and NS2. Okay. Suppose if n is equal to 6, I will have 6s2, right? And n minus 1 is 5. So 5d 0 to 1. And n minus 2 is 6 minus 2 is 4. So 4f 1 to 14. So this is the outer electronic configuration for a specific row which is called as lanthanoids. Okay. For lanthanoids. And if n is equal to 7, I will have 7s2 and n minus 1 will be 6d 0 to 1 and n minus 2 is 5f 1 to 14. So the elements which have this configuration is called as actinoids. They are called as actinoids. Okay, so these two rows occupies this lanthanoids and actinoids. Okay, so the first row, the from cerium to lutetium, they are called as lanthanoids, and from thorium till lawrencium is called as actinoid. Okay, so this is lanthanoid and this is all actinoid, and the chemistry of actinoid is very, very difficult. Okay, so why, they are all mostly man-made elements. Okay, and also they are radioactive in nature. If they are radioactive, then they will be unstable. So if something is highly unstable in nature, then it won't exist for a long time, right? So we cannot do any reactions having those elements which are unreactive, or which is radioactive, or which is unstable. So that's why the study of chemistry for actinoid is very, very difficult. Okay. The elements after uranium. So in the actinoids, we have uranium with the 92 atomic number, right? So the elements after uranium, from neptunium till lawrencium. So these elements are called as trans-uranium elements. Okay, the elements after uranium are called as trans-uranium elements. So again, coming to F block, you should study the outer electronic configuration. Okay, is it clear? Is it clear to all of you? So this is all about the blocks and its related informations. So we have covered all the 4 blocks. Any doubt, students? Yeah, no, great. Okay, okay. So thank you so much for all of your responses. Okay, Vikas, Sanket, and many Jenny, Shimoga, and you guys are so interactive here. Thank you so much for your response. Okay, if you're getting any doubt in between, you can ask me. Feel free to ask it. Okay. Now, let's go for the classification of metals, non-metals, and metalloids. So now, let me start with the metals. So in the periodic table, 78 percentage of the elements are metals. Okay, mostly they will occupy the left side of the periodic table. And metals are generally solid in nature, liquid in nature, or gas in nature. What is the nature of metal? Any idea for you? What is the nature of metal? Is it a solid or liquid or gas? Because who is asking that out? Yeah, I will come to this, my dear students. So Varalakshmi is asking me one question. Why uranium to lawrencium? So the elements which are present after uranium are called as trans. Trans means which is next to a particular element. That's why they are called as trans-uranium elements. Okay, which are actually more highly radioactive and unstable in nature. So those elements which are highly unstable in nature are grouped together, and they are given with a special name which are called as transuranium elements. Okay, each and every time they don't have to specify the name of the elements. They can call all the elements together as transuranium. So that's why they have did like that. Is that okay, Varalakshmi? Yeah. JNB Shimoga, except mercury, all are solid. Yeah, and Sanket is also saying mercury is a liquid. Very good, very good. So your answers are exactly correct, and the others also have given me the appropriate answer only. Okay, so they are generally solid, but with an exception. Okay, exception is mercury. Exception is mercury. So it is a liquid metal. Mercury is a liquid metal, and also we have gallium and cesium which have very low melting point. Very low means even if you keep a gallium metal in your hand, just your hand temperature or the body temperature or the room temperature is enough to melt that metal. Okay, I will show you that metals. You see here. So this is first picture is mercury, which is a liquid metal. Mercury is present in the thermometer, right? And this is gallium. If you keep this metal in your hand, it will melt. Okay, such a kind of very low melting point that it is having. So these are some of the exceptions. And some properties are also there for metals. Metals means they should have very high and very high melting point and very high boiling point. Okay, so this is one of the very important property of a metal. And it should be the good conductor of heat and electricity. So for all the electricity purpose and for heating purpose, we are using the metals only, right? Mostly we will be using iron, Fe. Okay, iron is used for the purpose, conducting purposes. And they are also ductile and malleable. So what is meant by ductility? The property which you can use your hammer and you can draw into thin wires are called as ductility. Okay, so the metals can be drawn into wires. So this is a property of a metal and they are also malleable. So malleability means you can beat in those metals into thin sheets, okay, and you can wrap it. So those property that is called as malleability, okay, which can be beaten into thin sheets is called as malleability. Very good, Bindu. Exactly correct. So these are the properties, some of the properties of metals. And again, I'm telling you, we will study all these properties in a brief manner in the other inorganic chemistry lessons. We have P block, we have T block, F block. So in those lessons, we will discuss everything in detail. Okay. So this is all about the metals and its information. The next is non-metals. So the non-metals occupy the top right-hand side of the periodic table. Okay. So non-metals are generally solid or gases, but with a very low melting point and boiling point. So for metals, the melting and boiling point will be very high. For non-metals, it will be very low. And also there is some exception, boron and carbon. They don't have very low melting point and boiling point. They do have some kind of high values. Okay. So this is about the non-metals. And some of the properties of non-metals are they are the poor conductors of heat and electricity. They don't conduct electricity. They don't conduct heat. And they are neither ductile nor variable. Okay. And means which you cannot be drawn into thin sheet or which you cannot drawn into wires. Okay. So it is just the opposite of metals. And these are the informations about non-metals. Next, we have one more classification which is called as metalloids. Metalloids are also called as semi-metals. Metalloids are also called as semi-metals. So you can find the metalloids mostly in P block. Okay, semi-metals are present in P block. The elements which show properties of both metals and non-metals are called as, this is non-metals, okay? So which shows the property of both are called as metalloids. Clear for all of you? Clear? I will show you the metals, non-metals and metalloids in the periodic table here. So all of you see here, mostly the S block pulley and D block pulley are metals. Okay. So the blue, orange, this blue, orange color and light pink, dark pink. So light pink is taking this part and dark pink. So they are all metals. F block is also metal. D block is also metal. S block also has metals. And coming to the light green and pink. So this one, okay, light green and this pink, entire pink, noble gases. They are called as non-metals. Okay, they are called as non-metals and this blue color is actually metal. And the orange color which you can see in between in the diagonal in the P block is called as metalloids. Okay, so we have few metalloids in the diagonal of the P block and those are also called as semi-metals. Clear for all of you? Any doubt from this? Shall we go with one question? Any doubt from the blocks information, students? And any doubt from the classification of metals, non-metals, and metalloids for anyone? No. Okay. So here is one question for you. In terms of periods and group, where would you locate the element with atomic number 117? All of you find out the answer and give me the answer in the chat box first. Where will you place the element with atomic number 117? Very good, Bindu. Yes, yes. Sanket, it is F block. Is it F block? 117 belongs to F block? No, it doesn't belong to F block. Yes. Very good, Varalakshmi. Yes, Bindu also have given me the correct answer. Sanket is, yeah, your answers are correct. So the period number is 7 and the group number is 17 and the block is P block. Okay. So in 17th group, the 117 element will be there. In 16th group, 116 element will be there. Okay. You don't have to get confused. So just see to the number. I'll show you the periodic table once again. You see here, octason is here. Before that, we have tennessine. So that is the element with atomic number 117. Okay, very easy. So the period number is 7. It belongs to the last row and the group number is 70. And if you're asked to find out the block, it is a P block element. Got it? Because 118 is the last element, no, in the periodic table which occupies the P block. So 117 will be just before 118, which occupies the P block again. Got it? Shall I go ahead with the one previous year question from NEET? Here is the question. Find out the answer first. The element with atomic number 114 has been discovered recently. It will belong to which of the following group and which electronic configuration? Find out the answer first. First, you need to tell me the family it belongs to, and then you have to find out the electronic configuration. Option A. Who is sitting behind the ID? Yes, sir. May I know your name, please? Vikas is also going for A. So let us wait for others' reply also. Okay, let's see what others are going to reply. You are Manamohan. Okay. Manamohan from which JNB? Manamohan is from which JNB? I think it is some other person who have given me the answer as A. JNB Ramnagar. Two persons are sitting with the ID Azer, I think. Yeah, two. One is capital A's letters. The other one is having the small letter Azer. So I think the small letter Azer is JB Ramnagar. The capital letter Azer student only have given me the answer. You also belong to the same JB. JB Ramnagar. Okay. Okay. Okay, great. Varalakshmi, just to see to your carbon spelling. I think it is by mistake, but no issues. I don't know what happened to JNV Yanam students. Why you guys are giving option C as the answer? What happened to you for JNV Yanam and Bhavnagar? It is not option B or C. It is actually option A. Option A is the correct answer. No. What happened to you guys? See, it is ending with the 1 4. 1 4 means it belongs to 14th group. 14th group elements are actually carbon family, carbon group. 13 means boron. 14 means carbon. 15 is nitrogen. 16 oxygen, 17 fluorine, 18 neon. So 14 means it is carbon. Okay. So carbon family and the electronic configuration will be NS2, NP2, right? I told you, no? So it will be 7s2, 7p2. All others have different number of electrons in its p orbital. Okay. So all of you should memorize the first 30 elements, atomic number from 1 to 30 you should memorize. Okay, from starting from hydrogen, ending with zinc, you have to memorize. Okay, then only you can able to answer such type of easy questions in a without wasting much of the time. Clear? So with this, the first half of the lesson, the classification of elements part is getting over. Okay. So now in the next slide, I'm going to move into the second half of the lesson, which is actually the trends in the properties of elements. We do have two properties. One is physical property and the other one is chemical property. So first, let's discuss about the physical property and its trends. Then we will go ahead with the chemical property. Okay. So there are four physical properties: atomic and ionic radii, ionization enthalpy, electron gain enthalpy, and electronegativity. So these four are the very important physical property which we are going to study in this lesson, and it will be continued in the P block, D block, F block lessons also. Okay. So in this lesson we will study the general thing, and coming to the specific lessons, there we will study about that atomic and ionic radii of that particular block elements. Okay. So the concept given in all these four are very, very important. So these are the physical properties of each element. So now let's start with atomic and ionic radii. Okay. Actually, one person have raised your hand. Yes, tell me, who is that? Who is that? Who raised your hand? Some of you have raised your hand, no? You have any doubt? I think he or she has raised her hand by mistake. Okay, no problem. Yeah, I'll give you one statement and a question along with that. You try to answer. Okay. The exact measurement of atomic radii is not possible. Why? Can anyone give me the answer for this question? Why the measurement of atomic radii is exact measurement of atomic radii is not possible? You all know what is an atom, right? So this is an atom. We have the nucleus and also we have electrons. In some cases, we may have inner shells which contains electrons. The distance between the nucleus and the electron is actually the radius, right? But the exact measurement cannot be made. Why? It changes its shape. It is micro. Okay. What are the other reasons which you know? Just think of it. Think of this question. Think and tell me whether you're getting any other answers for this. The position of electrons are not constant. Okay. What about others? Any other explanation you want to give? It is speed. Okay, you're trying to say that they will move at a very high speed. Okay. Any other? Any other answer? Every atom does not have same. Yeah, my dear. Every atom will not have the same size. But what is my question is the measurement of the radii, atomic radii for specific elements itself is difficult. Why? Fine. All your answers are partially correct here and there. Okay. So there are two reasons for this question. The first reason is the size of the atom is very, very small. One of you have given me the answer as micro, no? Yes, Ankit. This is, you're actually correct here. Size of the atom is very, very small. So we have an atom and we have the nucleus. So inside the nucleus we have neutrons and protons, and the electrons are revolving around the nucleus in each orbit. Okay. So this is an atom, and the size of the atom is very small, from which we cannot take out the radius itself. Okay. Then the second reason is they are called considered as an electron cloud. Electrons are considered as an electron cloud, and the nucleus is present at the center. Okay. And you can see that the electron cloud does not provide a definitive boundary. So here we don't have a definite boundary, right? I cannot draw a line here and I can make a circle. It is highly difficult. You know why? Because it is spreaded. Electron cloud is kind of spreading. It is spreaded around the nucleus. Yeah, very good, JB Bhavnagar. The electron cloud surrounding the atom does not have a sharp boundary. So these are the two reasons which says that we cannot able to measure the atomic radii having the exact values. Okay, very important reasons. So now how do we measure the radius then? How to measure the atomic and ionic radius? It cannot be calculated using direct method, but it can be calculated using indirect methods. Okay. So the indirect methods are, there are three methods from which you can find out. The first is from covalent radii, the second is from metallic radii, and the third is from van der Waals radii. So from these three things, you can get the radius of an atom. Okay, now let's see one by one. Let me take the covalent radii. So to get the covalent radii, I will take a covalently bonded molecule. For example, I will take chlorine. Okay, this is a chlorine molecule. It is covalently bonded. Covalently bonded means there will be two nucleus for this two chlorine, and they are overlapped. The orbitals of chlorines have got overlapped, and the distance between the two nucleus of the two chlorine is actually 198 picometer. So if I take the half of this, the half of the internuclear distance between the two covalently bonded atom is called as covalent radius. So if I divide 198 divided by 2, what will be the answer? What I will get? 198 divided by 2, which is actually half of this. 198 picometer is the internuclear distance, and half of this is equal to how much? Yeah, exactly. It is 99 picometer. And this is the radius, which is called as covalent radius for the chlorine. Alright, clear? Now, now, oh, how we taken 198 means it is calculated from the instruments. Okay, so we do have some instruments from which we can get the internuclear distance between the two bonded atoms. Okay, so that instrument will be connected to the system, and the system will give us the values. Okay, by doing the experiment. Got it, Varalakshmi? So we don't measure using a scale or using a tape or ruler. So we do have instruments to measure the internuclear distance. And from that, we are calculating the covalent radius by taking the half of it. Got it? Yeah. Now, this internuclear distance, which is actually the distance between the two nucleus, is also called as bond length. So, bond length divided by 2 is actually the covalent radius. Bond length is otherwise called as internuclear distance. So, the same thing divided by 2 will give us the covalent radius. Okay. The second radius is called as metallic radii. So, what is metallic radii? Half of the internuclear distance separating the metal cores. in the metallic crystal. So for example, what I will take? I will take copper. Copper is a metal, right? So the two copper atom will just touch each other. They will not overlap with each other. This is the property of a metallic bond. Two metals will just touch each other and they will not overlap with each other. And the distance between the two copper is actually the internuclear distance and its value is 256 picometer. And if I divide this by 2, I will get 128 picometer, which is the metallic radius of copper. Okay. So the half of the internuclear distance in the metallic crystal is called as metallic radius. Very easy. Clear. Then the third is called as van der Waals radii. So we will observe this van der Waals radii mostly in noble gases. Okay. Noble gases, I already told you, they won't react with each other. Okay. But when noble gases are existing in the monoatomic form, monoatomic means in a which has only one atom. Suppose if I take helium, so this is one helium and this is another helium. So when they are existing in their monoatomic form, the atomic radius is calculated through van der Waals radius. So I'll tell you how. They will come closer to each other. They will come closer to each other. So this is the first helium and this is the second helium. So when two atoms comes closer to each other, there will be some force of attraction acting between the two atoms. Okay. They will not form the bond. Okay, you should keep this in mind. They will not form the bond, but when they come closer to each other, they will try to have the force of attraction. Okay, when two-person come closer to each other, there will be some force of attraction. No, that's the same thing. But there is no formation of bond, but there are some attraction. So that is called as D. So this D is the internuclear distance now. If I take the half of it, it will give me the van der Waals radius. Clear for all of you? So now I will ask you a question. So this is the picture which denotes the covalent radius. The internuclear distance is denoted by D dash. And D dash divided by 2 is covalent radius. Now if I compare van der Waals radius and covalent radius, which radius will be more? Van der Waal or covalent? What is the order? Which radius will be more? Van der Waals or covalent? Very good. It is obviously van der Waals, right? Van der Waals radius is greater than the covalent radius. Got it? Because there is no overlapping. They are very far away from each other, unlike the case of covalent. So they will have the highest radius value. So that's why, because of this reason only, noble gases have abnormally large atomic radius. Okay. So if you take a particular period, if I take second period, okay, second period starts from lithium and it ends with neon. Neon will have the largest atomic radius value. Okay, so because of this reason only. So this is all about the atomic radius. Under atomic radius, we have studied three subcategories. Okay, so this is all about the concept. Now this is all about the physical property, which is atomic radius. Now, I am going to give you the trend of atomic radius across the period. So, in each physical property case, I will give you two trends. One is for across the period and the other one is on moving down the group. Okay. The first is regarding the trend of atomic radius across the period. So, I will take two periods for you. First is period 2, second is period 3. From lithium to fluorine, from sodium to chlorine. So in these two periods, what is the trend you observe from left to right? So for lithium is having 152 picometer, okay, 152 picometer, and fluorine is having 64 picometer. And here for sodium it is 186 and for chlorine it is, yeah, 99. So here I don't consider the 18th group. You should keep that in mind, okay? We don't have the noble gas here. We are studying till group 17. So the trend between group 1 and 17 is across the period, the atomic radius is decreasing. Atomic radius decreases across the period. Why it decreases across the period? Because the outer electrons are added in the same shell. If I take this period number 2, all the elements which are there in period 2 will have only the second shell as the outer shell. Because in period 2, the outermost shell will be 2. In period 3, the outermost shell will be 3. So if the period number is 2, the outermost shell will be 2. So if this is lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. So the size decreases because all of them have the outermost shell as second shell. So the electrons are getting added into the same shell. So this is the nucleus. This is shell number 1 for lithium. So there will be one electron in the outermost shell for lithium. So that will get attracted towards the nucleus. Whereas in case of beryllium, this is shell number 1 and this is shell number 2. In shell number 2, I have 2 electrons. So 2 electrons will get attracted towards the nucleus. And here 3 electrons will get attracted towards the nucleus. So the attraction is becoming more. So in that case, the contraction is also more. So the size is decreasing. And if I draw a graph between the atomic number and the atomic radius, so if the atomic number increases, atomic radius decreases. Or I can say across the period, the atomic radius decreases. Across the period, the atomic size or the atomic radius decreases. Is it clear for all of you? Any doubt? If somebody asks you why the atomic size is decreasing across a period, means you should be able to tell the distance between the nucleus and the outermost electron decreases. So the attraction increases and the size decreases. Got it? Shall we go ahead with the trend down, moving down the group? Is everything clear up to this? Shall I go for the trend of atomic radius on moving down the group, students? Do you have any doubt? Shall I? Yeah, yeah. So the next is trend of atomic radius across the group. So here also I will take two groups. One is group 1 and the other one is group 70. Okay. So group, just observe the values and tell me whether it is increasing or decreasing. Yeah, it is increasing. Why it is increasing? Along the group, the atomic radius increases. It is not decreasing. One of you saying it is decreasing. It actually increases. Why it increases? Because the electrons are added into the new shells. Because the electrons are added to the new shell, right? Because the electrons are added into the new shell. So lithium will have only, if this is the nucleus of lithium, it will have shell number 1 and shell number 2. If I go for sodium, it will have shell number 1, shell number 2, shell number 3. For potassium, I will have 1, 2, 3 and 4. So what is happening? The distance between the nucleus and the outermost electron increases. So the atomic radius will also increase. Okay. Force of attraction. The nucleus force of attraction will increase. So the size will also increase. Now if I draw a graph between atomic radius and atomic number for group trend. So here this belongs to group 1, lithium, sodium, potassium, rubidium and cesium. On moving down the group, the atomic radius is increasing from 150 picometer to 250 picometer. And for 17th group, which has fluorine, chlorine, bromine and iodine, again it is increasing. So on moving down the group, the number of shells increases, and because of this, the atomic radius also increases. Got it? So across the period, size decreases. On moving down the group, the size increases. Is it clear for all of you? So this is all about the atomic radii. We also have the second part of this, no, which is actually called as ionic radii, which is also called as ionic radii. Yeah. So now let's see this ionic radii. So let's see the estimation of ionic radii. So actually the distance between the nucleus and the outermost electron of the ion will give the ionic radii. Okay, the distance between the ions in ionic lattice is sum of the size of cation and anion. So this is a crystal lattice. The green color are anion and the purple color is a cation. Okay, let me take one cation and one anion which is bonded with each other. So this is the radius of cation and this is the radius of anion. This is the radius of cation and this is the nucleus and this is the radius of anion. Okay, if I add these two, I will get the distance between the cation and anion. Okay, clear? So this is the crystal lattice and the location of cation and anion. Now, how to measure the ionic radii? How to measure? First of all, tell me how will you get a cation from a neutral atom? How to get a cation from a neutral atom? I have a neutral atom. What neutral atom we can take? We can take sodium. Okay, so this is sodium atom. How will you get the sodium cation from sodium? By removal of electron, by addition of electron. Which one? Yeah, by the removal of electron. So if you remove one electron from sodium, you will get a cation. You will get a cation which is Na plus. In the same way, if I take another neutral atom, let me take Cl. And if the Cl gains one electron, it will form an anion with the formula Cl minus. Okay. Now, let me take, I'm also forming a cation for a particular atom. Okay. So, Cl is the neutral atom. Cl minus is the anion. Cl is the neutral atom. And let me take Cl plus also. Okay. Just not actually possible. And it is called as cation. Now, if I compare these three, the size of the anion will be more compared to neutral atom and the size of the neutral atom will be more compared to the cation. So generally you can write like this. If you are comparing a neutral atom with anion, anion will have the largest size value. Then if you compare a cation and neutral atom, cation will have the smallest size compared to the neutral atom. The very important relation. Clear to all of you? Any doubt from this? Shall I move ahead? I'll just complete this isoelectronic species, which is the second half of ionic radii, and then I will close the session, okay? You guys are joining very late. That's why I'm not able to complete. So please try to join on time, okay? So coming to isoelectronic, what are iso? Iso means same. Electron means electrons. The compounds which contains the same number of electrons, the species which contains the same number of electrons are called as isoelectronic species. So let me take an example, F minus. So what is the atomic number of fluorine? It is 9 and it is gaining one electron. So 9 plus 1 is 10. If I take sodium plus, atomic number of sodium is 11 and if sodium loses one of its electron, 11 minus 1 will be 10. If I take off O2 minus, atomic number of oxygen is 8 and oxygen is gaining 2 electrons. So 8 plus 2 will be 10. Now in all these three cases, we have 10 electrons. Means all these three are called as isoelectronic species but the size, the ionic radii will be different. All the three species will have different ionic radii. Now, how to find out which species will have the highest radius? I'll give you one relation. Using that relation, you can find out. So, the relation is ionic radii inversely proportional to atomic number. So, the one which is having the least atomic number will have the highest radius value. So, for fluorine, the atomic number is 9, and for sodium, it is 11, and for oxygen, it is 8. So, among these three, oxygen is having the least atomic number value, no? So, that will have the highest radius value. O2 minus will be having the highest size. So, next F minus with atomic number 9. Then, at last, only sodium plus. Clear? For isoelectronic species, size will differ, and to find out the order, you need to use this relation. Got it? Can you guys find out? You see, yeah, it is already given. For magnesium, the atomic number is 12, and if magnesium loses 2 electron, it will be a 10, and sodium 11 minus 1 will be 10. Both of them are isoelectronic, but the atomic number for magnesium is 12 and for sodium is 11. So sodium is greater in size compared to magnesium. Okay, so this is the order. And if I compare F minus and O2 minus, atomic number of O2 is very less. So that's why it is having the highest radius value. Clear? Any doubt from this for anyone? I hope it is clear for all of you. And since I'm running out of time, so I need to finish the today's session. So from next session onwards, please try to join on time. Okay, don't be late. So any doubt from today's class, students? No doubt. So before ending up the call, I would like to launch a poll. All of you please answer for the questions from the poll which I am launching, and then you can leave the class and you can go for the next class. Okay, so I have launched a poll. You guys can give your answer in the poll and you can leave. All right, thank you so much for listening. So meet you all in the next session. Thank you.